This video is sponsored by Mover Globes. Have you ever heard of Quipu? No, it's not a strange animal or a creature from myth. Quipu is the name of the recently discovered largest single structure ever found in the observable universe, and it's absolutely mind-blowing. Spanning an astonishing 1.3 billion light-years, Quipu is a massive cosmic structure made up of galaxy clusters, each holding hundreds or even thousands of galaxies. To put its scale into perspective, scientists estimate its total mass to be over 200 quadrillion times that of our Sun. That's a 2 followed by 17 zeros, a number so big, it's hard to imagine. Astronomers found Quipu, along with 4 other giant space structures, while they were mapping where matter is concentrated in our cosmic neighborhood. The superstructures are between 415 and 825 million light-years away from Earth. These discoveries are part of a larger effort to understand how mass is arranged across the universe on the largest scales. In the cosmic hierarchy, galaxies group together to form clusters. Clusters gather into even larger formations in a confined, mostly spherical, region called superclusters. And when galaxy clusters stretch across huge distances and link with one another together, they become superstructures, the biggest things we know of in the universe. So, what keeps these massive web structures from flying apart? The answer is dark matter, the mysterious, invisible substance that acts as the universe's glue. Without it, the gravitational pull wouldn't be strong enough to hold these vast cosmic networks together. There are 3 big reasons why studying superstructures like Quipu matters. First, let's talk about how galaxies move. We know that the universe is expanding, kind of like a balloon being blown up. If you put dots on a balloon and inflate it, all the dots move away from each other. That's similar to how galaxies move apart in space, and we call this smooth movement the Hubble flow. But galaxy movement isn't always smooth. They also have what's called peculiar velocity movement caused by the gravitational pull of nearby massive objects like other galaxies, clusters, or even larger structures. And this is where superstructures like Quipu come into the picture. Stretching over 1 billion light-years and containing unimaginable amounts of mass, Quipu's gravitational pull is strong enough to influence the motion of galaxies, both within and around it. Instead of simply drifting outward with the expansion of space, some galaxies get tugged toward these dense regions, creating deviations from the smooth Hubble flow. Why does this matter? Because it affects how we measure the Hubble constant, the value that tells us how fast the universe is expanding. Interestingly, when we measure this constant using nearby galaxies, we get one value. But when we look at the early universe, using things like the cosmic microwave background, we get a different one. This mismatch is known as the Hubble Tension, one of the biggest crises in cosmology. Some scientists think that huge structures like Quipu might be part of the reason for this mismatch. Their strong gravity interferes with galaxy movements, making it harder to get an accurate measure of how fast the universe is growing. The second reason why superstructures like Quipu are so important has to do with gravitational lensing. Because of their sheer mass, these structures act like giant cosmic magnifying glasses. Their intense gravity bends and distorts the light coming from galaxies far behind them, stretching and magnifying these distant objects in a phenomenon known as gravitational lensing. This effect can be observed across vast areas of the sky, but there's a catch. If we don't know exactly how big or heavy a superstructure is, the lensing can lead to false measurements. It can make galaxies look like they're in the wrong place or make them appear bigger or more stretched than they really are. So, to get accurate information about things like galaxy distances or how matter is spread out in space, we need to understand these giant structures better. While astronomers work to untangle the universe's deepest mysteries, understanding these cosmic giants remains crucial for our comprehension of the cosmos. The beauty of these cosmic structures extends beyond their scientific importance. They represent the magnificent architecture of our universe, showcasing how matter organizes itself on the grandest scales imaginable. From the smallest particles to the largest superstructures, the universe displays an intricate pattern of organization that continues to amaze researchers worldwide. Superstructures don't just influence the movement of galaxies or distort the light from distant stars, they even leave their mark on the oldest light in the universe, the cosmic microwave background, or CMB. The CMB is a faint glow of radiation left over from the Big Bang, stretching across the entire sky. As low-energy CMB photons journey across the universe, They sometimes pass through these huge galaxy clusters and superstructures regions so massive they create deep gravitational wells. When photons fall into these wells, they gain energy like a skateboarder picking up speed downhill. But as they climb out, they lose energy again, like going uphill. In a static universe, this energy exchange would balance out. But because the universe is expanding, the gravitational wells slowly become shallower over time. That means photons don't lose quite as much energy climbing out as they gained going in. This means they keep a little extra energy, and that shows up as slightly warmer spots in the CMB. This effect is called the ISW effect. It's really subtle, but when you look at big areas of the sky, the influence of massive structures like Quipu can add up, leaving a tiny but important imprint on the universe's oldest light. To find these gigantic structures in space, a team of astronomers from around the world launched an exciting project. Their goal was to look for huge groups of galaxies, each made up of at least 20 galaxy clusters, located between 415 and 825 million light-years from Earth. They used data from the Classics Cluster Survey, which uses X-ray observations from a special space scan called the Rosetta Sky Survey. X-rays were the perfect tool for the job, because the space between galaxies in a cluster is filled with scorching hot gas that glows brightly in X-ray light. By tracking this glow, scientists were able to pinpoint and study 345 galaxy clusters, each one a building block in the vast superstructures of our universe. The search led to an amazing discovery: 5 gigantic superstructures in space. These regions have a much higher number of galaxy clusters than the rest of the universe. The biggest one is Quipu, which appears prominently in the research data. Quipu includes 63 galaxy clusters, an incredibly dense gathering of galaxies. The other 4 superstructures are Shapley, Serpens Corona Borealis, Hercules, and Sculptor Pegasus. But here's where things get even more interesting. Some parts of the sky are hard to study because they're blocked by the bright stars, dust, and gas of our own Milky Way galaxy. Astronomers call this area the zone of avoidance. These regions act like a cosmic fog, making it difficult to see what's behind them. Scientists have mapped these obscured regions carefully. And here's the twist: Quipu appears to stretch right up to the edge of this obscured region. There are hints that the structure might actually continue on the other side, hidden behind the Milky Way's veil. Even more exciting, the bottom part of Quipu is located near another giant structure, the Vela supercluster, which is also partly hidden in that same zone of avoidance. While we can't say for sure yet, scientists think Quipu and Vela might be connected, forming part of an even larger cosmic web, possibly the biggest structure ever discovered in the universe. Researchers have mentioned in their paper that Quipu and the 4 other superstructures contain 45% of all known galaxy clusters, 30% of galaxies, and 25% of the matter. What's even more remarkable is that these kinds of massive formations aren't completely unexpected. They've actually been reproduced in simulations based on our leading cosmological model, Lambda CDM. This model, which combines Einstein's general relativity with dark matter and dark energy, forms the backbone of modern Big Bang cosmology. It successfully explains many of the universe's large-scale features, including the formation of vast structures like Quipu. Even though Quipu is the biggest superstructure in our part of the universe, it's not the one pulling on us the most. That role belongs to Shapley, which is the smallest of the 5 superstructures found, but also the most compact. It has so much mass packed into a small space that its gravity has a strong pull. Scientists believe Shapley is one of the main reasons why our own group of galaxies, the local group, is moving the way it is. So, we're being gravitationally tugged more by Shapley than by Quipu. But these superstructures do more than just move galaxies around, they also shape how galaxies and galaxy clusters evolve. Researchers have found that galaxy clusters within superstructures tend to host more galaxies than those outside. This points to the idea that superstructures create special environments densely packed, rich in hot gas that can influence how galaxies form, grow, and interact. To dig deeper, scientists are now using X-ray observations to compare galaxy groups inside these massive structures with those drifting in isolated regions of space. Their goal is to understand how the environment drives cosmic evolution. It's also important to know that these superstructures aren't forever. Over billions of years, gravity and cosmic expansion will cause them to break apart into smaller pieces. But right now, They are some of the biggest and most complex things we've ever found in the universe. By studying giants like Quipu and Shapley, astronomers are uncovering the universe's history, how galaxies came together, how gravity sculpted the cosmos, and how these colossal webs still influence what we see today. They even help explain why our measurements of cosmic expansion sometimes clash and why ancient light, like the cosmic microwave background, carries subtle distortions. In many ways, these titanic structures are key to unlocking the deepest mysteries of the universe. The discovery of Quipu and its fellow superstructures represents a remarkable achievement in modern astronomy. These cosmic giants remind us that the universe operates on scales far beyond our everyday experience, yet they directly influence the cosmic environment we inhabit. As we continue to study these magnificent structures, we gain deeper insights into the fundamental workings of our universe and our place within this vast cosmic web.